So in this question, we have to prove that cos A minus sin A plus 1 upon cos A plus sin A minus 1 is equal to cosec A plus cot A. So let's begin. So we'll start off with the LHS and try to reach the RHS. So let's copy the question. We have cos A minus sin A plus 1 upon cos A plus sin A minus 1. Now the first thing is, do I have any trigonometric ratio in the square form? No. So we can't apply an identity. Next, convert everything to sine and cos. Everything is already in sine and cos. Now the problem is here, I have 3 terms in the denominator. If we had 2 terms in the denominator, like 1 minus cos A, we could multiply by the conjugate, 1 plus cos A and simplify. But I have 3 terms over here, so I can't even multiply with the conjugate. So now what do? Look at the RHS. We want to show it as cosec A plus cot A. What is cosec A? It is basically 1 by sin A. Next, what is cot A? It is basically cos A by sin A. So in both these ratios, I have sin A in the denominator, right? So what I'll try to do is, I'll try to convert this expression into a cosec and cot. How do I do it? See, we have sin in the denominator in both the cases. So divide both numerator and denominator by sin A. I repeat, this is how you come to know what you have to divide with. We have sin A here, sin A here. So divide numerator and denominator by sin A. So I'll write it over here. That is dividing numerator, short form, and denominator by sin A. So see what happens. I'll copy the numerator. So we have cos A minus sin A plus 1. So divide this by sin A. Similarly, divide the denominator also by sin A. So cos A plus sin A minus 1. Divide this also by sin A. Is this clear? So see, what do we get? We'll split the numerator. So this is equal to cos A by sin A. So we have cos A by sin A minus sin A by sin A plus 1 by sin A. Is this clear? Upon, same thing over here, cos A by sin A plus sin A by sin A minus 1 by sin A. So we have cos A by sin A plus sin A by sin A minus 1 by sin A. So I'll continue this over here. So this is equal to cos A by sin A, that is cot A, minus sin A by sin A 1 plus 1 by sin A, that is cosec A, upon cos A by sin A, that is cot A, plus sin A by sin A, that's 1, minus 1 by sin A, that is cosec A. Is this clear? Now what do? See, we have a cot, we have a cosec. Is there an identity relating both the two? Yes. We know that 1 plus cot square A is equal to cosec square A. So what is this 1? This 1 is basically cosec square A minus cot square A, right? So we're going to replace this 1 over here by this identity over here. So see, we have, this is equal to cot A plus cosec A minus 1, right? So we have minus 1 over here upon cot A plus 1 minus cosec A. I just brought this together. So this 1 I'm going to replace by this identity over here. So instead of 1, I'll write it as cosec square A minus cot square A. Is this clear? Right? Now, see, we have, this is A square minus B square. So we can factorize it. So I'll get cot A plus cosec A minus A square minus B square is basically A plus B into A minus B. So cosec A plus cot A into cosec A minus cot A. I repeat, A square minus B square is A plus B into A minus B upon cot A plus 1 minus cosec A, right? Now see, in this term I have cot A plus cosec A. Here also I have cot A plus cosec A. So I'll take it common. So I will take cot A plus cosec A as common. So see, what remains inside? Cot A plus cosec A, so 1 minus. Now be very careful over here. Cot A plus cosec A gone, so this thing remains. Remember the bracket because we have a minus sign here. So cosec A minus cot A. Is this clear? Right? Upon cot A plus 1 minus cosec A. Is this clear? Right? So we've reached till here. Now we'll just open the bracket over here. So this is equal to cot A plus cosec A into 1 minus into plus cosec A minus cosec A, minus into minus plus cot A, right, upon cot A plus 1 minus cosec A. Now if you notice over here, plus 1 minus cosec A minus cosec A plus cot A plus cot A. So basically these two terms are exactly the same. I repeat, see 1 minus cosec A plus cot A plus cot A. So this and this cancel. So what are we left with? We are left with cot A plus cosec A. So this is equal to cot A plus cosec A, right? Which is basically a RHS. So this is equal to the RHS. So hence proved. So we have completed the question. So let me do a recap. The first step is copy down your LHS. Now the first thing we look for is any trigonometric ratio in the square form. So we can directly apply an identity, but clearly neither the trigonometric ratio and the square form. Next what we do is we convert everything to sine and cos. Now everything is already in sine and cos. Next we try to simplify the denominator. Now we have three terms over here. So it's pretty difficult to simplify. So what do? Check the RHS, cosec and cot. Cosec is 1 by sine, cot is cos by sine. So what I'm going to do is try to bring the LHS in cosec and cot form. Now in both the cases I have sine in the denominator. So simply divide numerator and denominator by sine A. So when you simplify, you'll get this expression over here. Now we have a cot, we have a cosec. Is there an identity involving cot and cosec? Yes. 1 plus cot square A is cosec square A. So what is 1? Cosec square A minus cot square A. So replace this 1 over here in the numerator, not in the denominator, in the numerator by this value. Now this is A square minus B square. So A plus B into A minus B. Now take cosec A plus cot A is common. We get this expression. Simplify, we get this. So this and this will cancel out. We get cot A plus cosec A. Right? So I hope the thought process is clear. So this is how you solve this question.